The concavity test, or sometimes known as the second derivative test, but that's really something different, so we're going to call it the concavity test, is a test very similar to the first derivative test, except we're using the second derivative, right? So f double prime of a function. And instead of using it like you do in the first derivative test to find where f is increasing or decreasing, we're using the concavity test to find where f is concave up or concave down. So if we're given f, there's really only two steps to the concavity test. So step one, we have to find f double prime, right? Because we need to use this to evaluate where f is concave up, concave down, and where it has points of inflection. And the second step, we need to make a sign chart. So let's do it given f of x right here. So first we have to find the second derivative. And to do that, we just differentiate this twice. So if we differentiate it once, we're going to get 9x squared minus 4x, and then this just becomes 0. Then we're differentiating it one more time, so we get 18x minus 4. So now we're going to use this, and we're going to find the critical numbers of this new function of f double prime so that we can make our sign chart. So the critical numbers are wherever a function equals 0 or wherever it equals undefined. So to find the critical numbers for this 18x minus 4, or for f double prime, we're just going to have to set this equal to 0 because we know it's not undefined anywhere, it's just a polynomial. So 18x minus 4 equals 0, and then we have 18x equals 4, and then x equals 4 over 18, or 9 over 2, or that's not right, 2 over 9. So this is our only critical number. So now we're going to use this critical number and put it on our sign chart. So we have 2 over 9. And now, and this is kind of an eccentric example, you're probably not going to get any function that ends up with just 2 over 9. It's kind of a weird number, but it doesn't matter. It's unimportant. So now we're going to find a number a little to the right of 2/9 and a little to the left. So this is good because we can use 1 and we can use 0. And now we're going to plug each of these numbers back into f double prime, so this equation right here. So if we plug in 0, we're going to have 18x times 0, which is 0, minus 4 is negative. It doesn't matter that it's negative 4, it just matters that it's negative. So then we plug in 1, we're going to have 18 minus 4 is 14, which is positive. So it doesn't matter the number, it just matters that it's positive. So since it's negative here, it's going to be concave down. We'll label our number line. We have negative infinity over here and positive infinity over here. So since it's negative, it's going to be concave down, right? Because whenever f prime or f double prime is negative, f is concave down. And whenever f double prime is positive, f is concave up. So that means since it changes sign here, this point right here is a point of inflection. So it means maybe f might look like this, and 2/9 is right here, right? Because it changes from concave down to concave up. So that's what a point of inflection is. And this is how you use the concavity test to find where f of x is concave up, down, and where it has points of inflection.